Every day, we consume delicious food and beverages, enjoying a spectrum of unique flavours. But how do we taste our food and drink? What is it about our tongue that gives us the ability to taste? And is what we've been told really the whole truth? If you've ever been curious about taste, you've probably seen a schematic such as this. Bitter tasting food is detected at the back, sweet and salty at the front, sour on the sides, and umami in the middle. This misleading representation gives the false impression that different tastes can only be detected in these divided taste zones. The truth, however, is a little more complicated. All over your tongue are little clumps housing up to a few hundred taste buds each. These clumps of taste buds are known as papillae. Papillae on the sides of your tongue are known as foliate papillae and hold 100 to 150 taste buds each. They are arranged in a way that resemble leaves. Papillae towards the back of your tongue are called valate papillae, which contain as many as 300 taste buds per unit. They are large and resemble bumps or hills. Finally, fungiform papillae sparsely cover the remainder of your tongue, each with just 5 taste buds. Fungiform papillae are most concentrated at the front of your tongue. Peculiarly, taste buds are also found on your pharynx, the back wall of your mouth, and your soft palate, which includes that dangly thing known as the uvula. Each taste bud has a taste paw with approximately 50 gustatory hairs protruding from it. When tasty food and drink contact these hairs, they send a signal into their respective gustatory receptor cell. Each gustatory receptor cell is specific to a particular type of taste, of which there could be as many as 8 depending on who you ask. These include the well-known 5, such as sweet, salty, sour, umami, and bitter, as well as the obscure, pungent and astringent tastes, with fat being the 8th. Gustatory receptor cells of a particular taste type can be found clumped together in particular parts of your tongue. This infamous schematic can give the false impression that only particular types of tastes can be detected in these respective zones. The truth, however, is that all of these taste zones can detect all kinds of taste, but each zone experiences a greater response to one distinct type of taste due to high concentrations of a particular gustatory receptor cell type. Gustatory receptor cells for bitter taste are found in the highest concentration towards the back of your tongue, as well as on the pharynx and soft palate. High concentrations of bitter gustatory receptor cells towards the back of the tongue and mouth are necessary for eliciting a gagging reflex to vomit up any toxins that may be harmful to your body. Thanks, taste buds. Gustatory receptor cells for salty and sweet tastes are found in the highest concentration toward the front of your tongue, with sour towards the sides and umami in the middle. Within taste buds are basal cells, sort of like baby gustatory receptor cells, that mature into fully functioning taste cells should their predecessors die off. This allows you to continue to taste even after you burn your tongue on a hot cheese toastie, though it will likely take several days for you to get your taste back. Upon receiving input from their gustatory hairs, these gustatory receptor cells send information on taste to your brain to be made sense of. First, they arrive at the nucleus of the solitary tract, located in the brainstem, from where they travel to your primary gustatory area, located in your insular cortex. They do this by sending their information along your tongue's sensational expressway, gustatory afferent axons. These axons are special visceral afferent fibers of cranial nerves 7, 9, and 10. Your tongue detects the food with its unique taste, and your brain makes sense of it all. And that is how to taste.